The objective of this video is to show you how to use trigonometric identities. So let's begin by stating those identities, and then I'll do some examples to show you how to apply them. So we have, first off, reciprocal identities. Reciprocal identities relate the trig function with its reciprocal function. So we kind of have already talked about this, but this is a way to explicitly state it, that sine of theta and cosecant of theta are reciprocal, so we can write them in terms of the other. So sine theta is 1 over cosecant. Cosecant is 1 over sine. Cosine and secant are reciprocal, so cosine theta is 1 over secant theta. Secant theta is 1 over cosine theta. Tangent of theta is 1 over cotangent theta, and cotangent is 1 over tangent theta. Then we have quotient identities, that tangent of theta is equal to sine of theta over cosine theta. And if you remember how we defined sine of theta was what? Opposite over hypotenuse. And cosine was adjacent over hypotenuse. Well, when you multiply by the reciprocal, the hypotenuse expression will divide out, and you're left with opposite over adjacent, which is the way we define tangent. So in terms of sine and cosine, tangent is really sine over cosine, and therefore the reciprocal cotangent is a reciprocal of that, which would be cosine over sine. Pythagorean identities. Sine squared theta plus cosine squared theta is equal to 1. And that follows from the fact that x squared plus y squared is equal to 1. Well, it's equal to c squared, but if we let the hypotenuse be 1, it turns out that we get this Pythagorean identity. And then you can put these in terms of the other functions. 1 plus tangent squared is equal to secant squared. 1 plus cotangent squared is equal to cosecant squared. Cofunctions of complementary angles. This is kind of what we were talking about before. Do you remember how we said that sine of 30 was equal to the cosine of 60? So the sine of an angle's complement is equal to the cosine of that angle. The cosine of an angle's complement is equal to the sine of that angle. So let's go through and use some trig identities to find out some values if we're given that sine of 30 degrees is 1/2 and tangent of 30 degrees is the square root of 3 over 3. So these are things that we've already talked about. So how could we define, or find rather, cosecant of 30 degrees? Well, we know that cosecant is what? It is 1 over sine. So cosecant of 30 would be 1 over sine of 30 degrees, which in this case would be 1 over 1/2, which would be simply 2. What about the cosine of 30 degrees? Well, I mean, you probably know it because we've just talked about it, but we can do it in terms of the Pythagorean identities. If we know that sine squared plus cosine squared has to be 1, that would tell us that sine squared of 30 plus cosine squared of 30 is going to be equal to 1. Well, sine squared of 30 would be 1/2 squared plus cosine squared of 30 is going to be equal to 1. Well, 1/2 squared is 1/4. So 1/4 plus cosine squared of 30 degrees is equal to 1. Well, we can subtract 1/4 from both sides to get cosine squared of 30 degrees. It's equal to 1 minus 1/4, which is really 4/4 minus 1/4, or 3/4. And if we apply the square root to take off the square, we get that the cosine of 30 degrees is the square root of 3/4, which if we apply that to the numerator and denominator, get the square root of 3 over the square root of 4, which is 2. Okay, so just a note for you, sine squared, when you see that notation, you're really talking about sine of 30 degrees squared. Okay. Now, how can we find the cotangent of 60 degrees? Well, we know that cotangent is what? It's the reciprocal of tangent, which is going to be, if tangent is sine over cosine, then cotangent would be cosine of 30 degrees over, I'm sorry, not 30. Let's back up. In fact, we can do the last one. Let's do that last one. I probably should have put these in the other order. Let's do cotangent of 30 degrees first, and then we'll go back to cotangent of 60 degrees. Cotangent of 30 degrees would be cosine of 30 degrees over the sine of 30 degrees, since that's the reciprocal of tangent. Cosine of 30 degrees we know is the square root of 3 over 2. And then the sine of 30 degrees is 1/2. So when we multiply by the reciprocal, the square root of 3 over 2 times 2 over 1, which is simply going to be the square root of 3. So cotangent of 60 degrees is going to be cosine of 60 degrees over sine of 60 degrees. But if we use the cofunction rules, cosine of 60 is really the same thing as what? Yeah, the sine of its complement, which is 30 degrees. Sine of 60 is the same as the cosine of its complement, or the cosine of 30 degrees. Well, that's going to be what? Sine over cosine is really tangent, so we know that it's the square root of 3 over 3. Now, let's use the trig identities to find the values. If cosecant theta is 3, and secant theta is 3 times the square root of 2 over 4. So what would sine of theta have to be here? Well, sine is defined to be 1 over cosecant of theta. So we're talking about 1 over 3. What about cosine theta? Cosine is going to be 1 over secant. So here we're talking about 1 over 3 on the square root of 2 over 4. So here we would have to do 1 times the reciprocal, which is 4 over 3 on the square root of 2. But we don't leave it in this form. We multiply by the square root of 2 over the square root of 2 to rationalize the denominator. So we really have 4 on the square root of 2 divided by 3 times the square root of 2 times the square root of 2 is the square root of 4, which is 2. So really we have 3 times 2, which is 6. So finally we can reduce the 4 and the 6 to be 2 on the square root of 2 divided by 3. Now, what is tangent of theta? Tangent of theta would be sine of theta over cosine theta, right? Should have left myself more room here. So, sine is 1 over 3 divided by 2 on the square root of 2 over 3. So when we multiply by the reciprocal, we really get 1/3 times 3 over 2 on the square root of 2. But those 3's divide out to get 1 over 2 on the square root of 2. And so we can multiply by the square root of 2 over the square root of 2. So this would become the square root of 2 over 2 times 2, which is 4. Now, what about the secant of 90 degrees minus theta? Well, secant we can think about as 1 over cosine. There's several ways to do these problems. So we could say that's really 1 over cosine of 90 degrees minus theta, right? But we just talked about the cofunction angle, so this is really 1 over sine of theta. But what is 1 over sine of theta? It is cosecant of theta. So cosecant of theta is 3. Now, let me show you some problems that don't have you really working with angles at all. They are just trying to use trig identities to show one side of an equation is equal to the other side. And so I'm going to work a few of these for you. And I'll tell you, there's really no right or wrong way to do these. You just pick a side and try to work with it, simplify it as much as you can to see if you can get the other side. Let's start with tangent of theta times cotangent of theta is equal to 1. Well, that hopefully makes sense because tangent and cotangent are reciprocals, but we can write them in terms. So if we start with tangent of theta times cotangent of theta, we can write that as tangent of theta times, we can rewrite cotangent in terms of tangent as 1 over tangent of theta. But we know that divides out, so we do get just 1. So we've proved that tangent of theta times cotangent of theta is equal to 1. Now, in the next one we have cosecant theta times tangent of theta is equal to secant of theta. So kind of think about what all those things have in common. Secant is a reciprocal of cosine, cosecant is a reciprocal of sine, and tangent is sine over cosine. So if we can take the left hand side, write it in terms of sine and cosine, we can eventually get to the right side. So let's say we have cosecant theta times tangent of theta. So if we rewrite cosecant theta to be 1 over sine theta, tangent of theta is going to be sine theta over cosine theta. You see what's happening here? The sine theta is common, so it divides out, so we're left with 1 over cosine theta. But 1 over cosine theta is exactly secant of theta, so we have proven what we needed to prove. Oops. Okay. Here's some that look a little bit more involved. We have 1 plus cosine theta times 1 minus cosine theta, and we have to show that's equal to sine squared theta. So if you kind of think about something we know that cosine squared plus sine squared is equal to 1. So maybe we can use that in here somewhere. But let's look at this product. If we multiply, 1 times 1 is 1. Remember to do the outer would be negative cosine theta. The inner would be plus cosine theta, which those divide out. And then cosine theta times negative cosine theta would be minus cosine squared of theta. So now in place of 1, we're going to put that 1 is really sine squared theta plus cosine squared theta. And we're going to leave that minus cosine squared that we had. Well, what happens there? Yeah, the cosine squared subtract out, and we're simply left with sine squared theta. Now the last one of these that I want to work is sine theta over cosine theta plus cosine theta over sine theta, and we need to show that's equal to cosecant theta times secant of theta. So if we start with the left and we try to combine those fractions together, Well, to add fractions, remember, what do you have to have? Right, a common denominator. So since there's nothing in common, our denominator's product will be the common denominator. So we would need to multiply the first fraction by sine theta over sine theta. And we need to multiply the second fraction by cosine theta over sine theta. I'm sorry, cosine theta. Looked at what I had there. So notice this gives us sine theta times sine theta is sine squared theta over cosine theta times sine theta plus cosine theta times cosine theta is cosine squared theta over sine theta times cosine theta. So now we have the same denominator, so we can add the numerators to get sine squared theta plus cosine squared theta over cosine theta sine theta. But what do we know about the top? It's one of our identities. Sine squared plus cosine squared is 1. So we have 1 over cosine theta times sine theta. And let's take a look at what we're trying to get to. Trying to get to cosecant times secant. Well, what is cosecant? It's 1 over sine. Secant is 1 over cosine. So we really want to eventually get 1 over sine times 1 over cosine. Well, we can do that here because notice that we can rewrite this as a product. We can write this as 1 over cosine theta times 1 over sine theta. And 1 over cosine is secant theta times 1 over sine, which is cosecant theta. And that is exactly what we needed to get to. I mean, the order is different, but in multiplication it's commutative, so it doesn't matter. Okay? So don't be afraid to work with these. You're just going to try to apply everything that you know. Kind of take a look at how you can rewrite the other side. That might give you some tricks about how to start with the process that you need on one side of the equation. But if something takes you down a wrong path, then back up and try to use another identity. If you have any questions on these, don't hesitate to contact me.